There are different ways to solve equations. So this one deals with substitution. So today's date, and then this my 5th period class.
It's only the 23rd.
Yes. Okay, we did graphing already, but I know a lot of y'all, including me, I don't like to solve for y every time and then graph it. So this is a different way of solving equations. So there are 3 different types of systems of equations, and this gives us how to solve each one. So if one equation is set equal to a variable, then these are the steps that we'll do. So look and see how this says y equals 2x plus 1. So this one is already set equal to y. It's already solved for y for us. This one has x plus 3y equals negative 12. So substitute means we are going to substitute in. I'm going to use a highlighter, so if y'all want to use a highlighter, you can. Since this is y, I'm going to substitute in this for y. So x stays x plus 3, and y is now 2x plus 1 equals negative 2. So what we did is we took these 2 equations, we made it into one equation with only one variable. When we do that, we can solve an equation that only has one variable to find out what that equals. So then I'm going to put, we're not going to actually solve this because this is just the steps. Then solve for x. And that'll get you the x value. And then to find y, you're going to plug in whatever value you get for x and solve for y. Okay. Last step. Sub in x to find y. These are just the steps so that you'll know these steps as we go and apply them on the inside of this foldable. So let me explain it one more time. This says y equals 2x plus 1. So I'm combining these 2 equations. So since y is 2x plus 1, I'm plugging in that number for y here. And I rewrite the equation. Still have x plus 3. But instead of writing y, I'm writing what y equals, which is this 2x plus 1. Then I have that equation. Then I'm going to solve for x. After I solve for x, please stop. Last step, sub in x for y. Okay, so now go to the inside of this. And we're going to do those steps inside here. So this says x equals. So x has been solved for. So we're going to substitute in this 3y minus 9 for x. Because this is already solved for one variable. So we do 5 parentheses. Instead of putting in x, I'm going to put what x equals. This 3y minus 9. Minus 2y, because we don't need to substitute anything there, equals 7. Then we're going to solve for y. So the way we solve for y, we have to distribute and solve for y. So 5 times 3, 15y. 5 times the negative 9 is minus 45. And then minus 2y equals 7. We need to solve this out. So combine like terms, 15y minus 2y. 13y minus 45 equals 7. So I need to get y by itself, so plus 45. So 13y equals 45 plus 7, 52. Divide by 13. So y equals 4. So we have y equals 4. So we know what the y value is. We don't know what x value is yet. So once we solve for y, we put last step sub in, well, instead of x, we're going to say y to find x. I'm going to write it in a different color. Sub in y to find x. So we look and see which equation would it be easier for us to sub in y? Would it be here or would it be here and solve for x? The top one, because it already says x equals. I'm going to say x equals 3 times, instead of putting y, I'm going to put 4 minus 9. Why? Because we found that y equals 4, so I'm already plugging that in here. So then x equals 3 times 4, 12, minus 9, 3. Yeah. So we found what x and y equal. So now we plug that into just coordinates, x comma y. So it's 3, 4 is the solution to this system. So whenever we have a test over this, I'm going to say, solve this system by graphing, or solve it by substitution, solve it by elimination. And then there will be questions that say, solve it by whatever method you choose. So right now we're using substitution. Okay, so let's look at this next one. Negative 6y plus negative 6x plus 3y equals negative 12. And then y equals 2x minus 4. So our first step is to look and see which one's already been solved. Inside bottom one, y equals 2x minus 4. So that means this 2x minus 4 is going to go in the place of y.
What? So why did you put in place of the x?
Oh, because it says x equals. This says y equals, so that's why it goes in the place of the y. Good question. Yeah. So since this says y equals, this goes in for y. This says x equals, this goes in for x. All right, so we're going to do negative 6x plus 3 times y is this 2x minus 4, 2x minus 4 equals negative 12. I'm going to solve this out, so we'll distribute that. So negative 6x plus 6x minus 12 equals negative 12. But this negative 6x and positive 6x will cancel each other because it becomes 0. So it's negative 12 equals negative 12. Is that true?
Yes.
It is true. So anytime we get that, this is going back to when we solved equations at the beginning of the year. When we get two things that are equivalent to each other, that means that that x value equals all real numbers. It means x can be anything. I can plug in anything for x, and this equation would still be true. But now we're dealing with systems of equations. So if x equals any number, then that means y equals any number. And there'll still be a system of equations that any number can be replaced for x and y.
So would your coordinate be real number, real number?
Real number, but what does that actually mean? Huh? Many solutions. How did you know that? It's the same slope and same y-intercept. So when they are the same, it's going to say a true equation, and x is going to equal anything, y can equal anything. Just to verify that, let's look at this, and let's solve this for y. Just to see, is it really the same equation? Let's solve it for y. So we need to add 6x to both sides. We have 3y equals 6x minus 12. Divide by 3. So y equals 2x minus 4. Is that the same? Mm-hmm. So anytime it's the same equation, our solution is infinitely many. So the way it shows up when we're doing substitution is that you have this true equation and it's all real numbers.
How would that show up on the graph?
It'd be the exact same line on the graph. All right. Okay, so let's go to the next type of system. No equation. No equation is set equal to a variable. So we have 2x plus y equals 10 and 4x plus 2y equals negative 3. So we're still having to do substitution, but we've got to figure out where we're going to substitute in. So I just want to find the easiest way. So out of these two equations, which one's easiest to find one variable equals something? Top one. What would we need to do? Subtract the 2x, yeah. So it's y equals negative 2x plus 10. You just want to look for the easiest way to get one of the variables by itself. So that means we have the y is this 2x plus 10. So this is going to go input for what variable? For y, because it's y equals. So it's got to go here. We're not solving this one on the top. We're just writing how we do it. So 4x plus 2 times negative 2x plus 10 equals negative 3. And then what would we need to do? Yeah, then solve for x. So first thing we had to do was solve one of the variables. And then we can get to where we were at the previous equation. Last step, sub in x to find y. Okay, so let's do one of those on the inside. We'll see if we can get both of them. All right, let's look at these. We have 4x plus 5y equals 11 and y minus 3x equals negative 13. So think about which one would be easiest to solve for one of the variables. The bottom one, so how do we do that? Yeah. So we get y equals 3x minus 13. So where are we going to plug this in? On the 5y, yep. So this y is going to be replaced with that 3x minus 13. So we're using this 4x plus 5 times 3x minus 13 equals 11. So we want to distribute. We move 4x plus 5 times 3 is 15x. 5 times a negative 13. Negative 65 equals 11. Then we get 19x minus 65 equals 11. Plus the 65. We have 19x equals 76. And we divide by 19. What do we get? Yeah. So we have x equals 4. Where would be the easiest place to plug in so we can find y now? We're at 3x minus 13. So y equals 3 times 4 minus 13. Yeah, x is 12 minus 13. So y equals negative 1. Oh, it's xy. X comma y. So what's x? 4 comma negative 1 is our solution. But we're going to finish this last one tomorrow. Shout out to 5th period. No specifics. See ya.